This time we are going to discuss NAND gates. Always keep in mind that you cannot leave any input connected nowhere. The input is supposed to be connected to VCC, to ground, or to the output of the other gate, or let's say to pull down resistor or pull up resistor. Okay, so let's verify which one of these circuits is correct and which one is not correct. First circuit, I made connection by connecting the first input to the second, and I have to verify if this is right move. Okay, so NAND gate is nothing else just AND gate and inverter. Okay, so first let me talk about product. Okay, I'm going to talk about AND operation, and after that we are going to talk about inversion. So I have A, and this same A will go over here. And it's very similar situation like with a AND gate. We have A times A times B. And because we have inverter, I'm going to draw bar over this expression. Okay, so I have A times A, we have one already, is A times B naught. And this is nothing else, just the logic expression for the NAND gate, two input NAND gate. So this connection is correct. So I can make this connection in order to convert three input NAND gate to two input NAND gate. Let's take a look at this example. This time I use 4 input NAND gate and I want to make 2 input NAND gate. I made the connection by connecting first input and second together with the third. So what I'm going to have, this A will go to the first, A will go to the second input, and A will go to the third input. So I have A times A times A times B. And because I have negation indicator, I'm going to draw bar over this expression. And remember, A times A times A is A times B in this case. Okay? Let me remind you, we have A times A times A is A because A could be 1 or could be 0. So if I have 0, 0, 0, it's going to give me 0. So that's why I write A. 1 times 1 times 1 is 1. So that's why A times A is equal A. Next, you're supposed to copy the bar, negation bar. So I can write simply this is A, B, naught. Okay, so this is nothing else, just the logic expression for the two input NAND gate. Also, we can make this connection and we are going to create two input NAND gate from 4 input NAND gate. Let's take a look at this example. I have pull-up resistor, and anytime I use pull-up resistor, I'm going to send one logic level 1 to the first input, and I have over here A and I have B. If I want to verify if I'm correct, simply keep in mind this is nothing else, just 1 times A times B, and because I have negation indicator, I'm going to draw bar over this expression. 1 times AB is simply AB naught. As you can see, this is the logic expression for two input NAND gate. So this connection is also correct. Let's take a look at this one. Again, I use pull-up resistor, and simply I'm going to have over here 1, 1, and I have A, B. So I have 1 times 1 times A times B. And because I have negation indicator, I have bar over my whole expression. 1 times 1 is 1. 1 times AB is AB. That's why I'm going to have AB with bar over this expression. So again, this is nothing else, just 2-input NAND gate. So this connection is also correct. So if you have 4-input NAND gate and you want to make 2-input NAND gate, you can use this option too. Let's take a look at this one. We have A, B, and I have what? 0. So I have A times B times 0. And because I have negation indicator, I'm going to draw the negation bar. A times B times 0 is equal 0. Okay, if you want to find complement of 0, or if you are going to invert 0, answer is going to be equal 1. And this is not logic expression for 2-input NAND gate. Okay, we're supposed to obtain A, B with bar over expression. We got 1. So that's why this connection is incorrect. And basically, these are the 4 options which you're supposed to use in order to make 2-input NAND gate for these gates.